已解锁，请启充二口。
哎，我现在我进来看到，不要那是一个。等给他扣啊，不是这样啊？你跟他我要不是就10刀又10刀又有来，又是不看牌的，对，知道了。还是一定到我，他现在用怕还是有刀，现在一定是输的，不再出来的。等人先，他们先看一些 video。然后这人是谁？看他的 video。啊，对对，哎，不是，是人家给那个配 NVIDIA CEO，听过他讲话，是，听过他讲话，也听过他的 talk，他的 speech 啊，每次是很 logic 的，可能你不知道什么是 AI 啊，但是你可以跟他说，你要听得懂他在说。Something great. It's not easy to do. And when you're doing something that's not easy to do, you're not always enjoying it. I don't love every day of my job. I don't think every day brings me joy, nor does joy have to be the definition of a good day. And every day I'm not happy. Every year I'm not happy about the company. But I love the company every single second. And so I think that what people misunderstand is somehow the best jobs are the one that brings you happiness all the time. I don't think that that's right. You have to suffer, you have to struggle, you have to endeavor, you have to do those hard things and work through it in order to really appreciate what you've done. And there are no such thing that are great that was easy to do. And so by definition, I would say therefore, uh, I wish upon you greatness, which by my way of saying it, I wish upon you plenty of pain and suffering. And so 听得懂啊？听得懂在讲什么？对他来说是你要经过那些 struggle 的痛苦才可以有 happiness。OK，等一下我一直就一起跟他评论讲那种，一进一个公司就 happiness，要慢慢的我理解。OK，他说如果不 happy，他要怎样？他至少也要很爱那个公司，所以我希望你们就很爱数学，不然的话你很辛苦。真的，你想想看，你爱不爱他？就你爱做一件事情，你才去持续去做，OK，不然的话你就会很痛苦。还有这个人很有意思哦，他每次助人都是，人家是祝你开心嘛，祝你幸福嘛，他是祝你得到痛苦和 suffering 啊，挣扎。
suffering。对，就很有趣，这个人很有趣。他的那个他的 stock 不是在一年内，他的那个股市从一年内30块一个股，哎300块一个股到1400，现在你已经失去机会了，你现在买来不及了啊？什么507？哦，OK OK OK，Yeah，OK OK，还有他的那个公司最近出一个很厉害的一个 chips，是 for AI 的，就是 for AI development 电脑 super computer Blackwell chips，就他们出吧，现在目前，OpenAI 跟他们买啊，还有一个他跟 Stanford 的人讲的，
one of my I think one of my great advantages is that I have very low expectations, and I mean that. Most of the Stanford graduates have very high expectations, and you deserve that because you came from a great school. You were very successful. You're top of your class. Obviously, you were able to pay for tuition, and then you're graduating from one of the finest institutions on the planet. You're surrounded by other kids that are just incredible. You should really have very high expectations. People with very high expectations have very low resilience. And unfortunately, resilience matters in success. I teach it to you, except for I hope suffering happens to you. And I was fortunate that I grew up with my parents providing a condition for us to be successful on the one hand, but there were plenty of opportunities for setbacks and suffering. And to this day, I use the phrase pain and suffering inside our company with great glee. And the reason, and I mean that, boy, this is going to cause a lot of pain and suffering. And I mean that in a happy way because you want to train, you want to refine the character of your company. You want greatness out of them. And greatness is not intelligence. Greatness comes from character. Character isn't formed out of smart people. It's formed out of people who suffered. And so that's it. And so if I could wish upon you, I don't know how to do it. For all of you Stanford students, I wish upon you ample doses of pain and suffering.
对，听得懂啊？是顶层在 summarize 这样子。为什么 pain suffering 啊？他说，如果你有很高的期望，通常呢，你的抗压性很低。OK，你很容易被打败，很容易失望啊，什么之类的，对吧？哎，你们是属于草莓族嘛？啊，什么是草莓族啊？一折就断，报纸不是每次登草莓族，现在小孩子，希望你们不是了，吧？就是什么10后，OK OK，10后，right，so 我们很容易变成草莓族啊，但是就是说，你们在这种高压的学习啊，或者 assignment 等等说，这样你们可以把你们的抗压性练起来。哦，这个只是 assignment 罢哦，你现实生活中遇到的那个问题啊，是更大的。可能你的家人啊，对，可能你的经济能力啊，对不对？那个是没有饭吃的状态哦。你现在是家人给你饭吃哦，对不对？真的，你不愁吃穿。比如说我以前做学生也是这样，还有政府给我钱，我不用担心啊，我天天就是读书玩吧，打毛球。但现在假设我一天被厦门炒掉，然后我吃什么？好面，对吧？我们 OK，so I mean 就需要把你们自己的那个抗压性练起来。OK，所以他说啊，不是聪明的人就有这个东西啊，这东西是每个人都可以训练起来。好，这样。 说现在啊，你做的题目不是还有答案的，以后做的题目是没有答案的，生活中啊没有答案的。OK，别人的答案也不适用于你的，你自己要走出你自己一条路。OK，说从现在你就要开始走了，不然你出了学校没有东西在保障你了。OK OK yeah right. So I mean yeah 说啊 OK，等一下我们break 的时候看一个比较好笑的，等一下我们 break 的时候看一个比较好笑的。OK， so let's start with a quiz. Okay, so how many how many orientation you can put on the line? Orientation is like 方向. Okay? How many orientation you can put on the line? 小杨 two. What are the two? Positive or negative? So how do you define positive or negative? Okay, so either you can go to the right or you can go to the left. Okay, so these are the only two orientation. Okay, so how about 2D? How about for a plane? How many orientation you can have on a plane? Orientation now. What kind of orientation you can put on a plane? Orientation on the plane. 有曾经听过吗？没有。Okay, so there are two orientation you can put on a plane. Either you do anti-clockwise or either you do clockwise. Okay, so anti-clockwise or clockwise. Okay, so these are the two orientation. So pretty much this is the reason why you draw x-axis at the horizontal and the y-axis on the vertical. Okay, because by default, our orientation is anti-clockwise. We call the anti-clockwise positive orientation, like what Xiao Yang said just now. So for the line going to the right is positive. Okay, carry on now. How you draw x-axis? You also draw it to the right. So we call this positive. Make sense? Now how to remember this clockwise and anti-clockwise thing? So this is how you started drawing your XY plane, right? So you go from X and then to the top. So you have an anti-clockwise orientation. So here is the anti-clockwise orientation. Seldom people will draw YX. Okay? Usually we draw XY because this is the positive orientation that we. How about 3D? If you go 3D, three-dimensional. So how about add another axis? So you go from X, Y. Typically, how you draw the Z axis? Going up. Okay, so there's a rule. governing this orientation here. So what's the rule here? If you learn physics, this is the right hand grip rule. And so if you turn from x and y, turn from x to y, and then your thumb will point up. Yeah. Okay, so this is one of the orientation in 3-dimension. So left hand grip rule will be the other convention. Yeah. Does it make sense? Any question? No? I'm just telling you some facts. Yeah, later on, maybe we will use it. Okay, so far, any question about this orientation? 有问题吗？还是你想问为什么这样子做？hello，没有反应。有问题吗？有反应吗？没有也没有，有又有。啊，没有反应。OK。Yeah, so I mean, 我确实是需要拿一些反应从你们，我才知道你们有听进去还是没有听进去。没有听进去，你要让我懂，这样我才知道，哪里出问题。可能我表达有问题吧，我需要看看你要知道的点是什么，才可以解释给你。OK 吗？你一定要跟我讲。好，因为你看川渝好像最近都没有抄 note，是不是？我看到你前几个礼拜还会写东西，是不是？现在几乎没有写，我觉得是对的。你在我班这样做是对的，你只要注意听我讲就对了。你回家才算。好，因为在我班我不是训练你们抄东西，我不是训练抄，我是训练你们耳朵听。OK，你要听进去，看看我讲的东西对了不对，不对你就可以 point out。或者你可能有一点 misconception，我可以帮助你，这样子，OK 吗？好，So I mean，从我出来的学生应该是能够 critically 去理解人家在讲什么的，然后可以分析出人家在讲的对还是不对。OK，所以我希望你们从我班上毕业过后，可以有这份能力，这份能力很重要，在这社会里面，这份能力很重要。哎，你看又没有反应了，又没有反应了。OK，so，你可以质疑我，但是你要先把我的话听进去先，OK，不然很常发生一件事情，就是当你质疑一个人之后，你会听不进他讲什么东西，then 你就会 miss 掉很多 information，OK 吗？你可以反驳我，没有问题的，不要把我当老师。如果你觉得有问题的话，不要把我当老师，你可以反驳我。所以我这样你叫我 key Seng 就好，不要把我当老师。老师就是要拿来推翻的，好不好？推翻你的老师，真的，要不然讲进步啊，不可能啊！如果你不想推翻牛顿的话，那有爱因斯坦。你明白我讲什么吗？OK，如果你觉得老师这个字对你太沉重，不要叫我老师。OK，我不是传统意义上的老师。OK，真的，Yeah，it's OK 的。我们互相提醒。OK，right。So now we will continue with partial derivative. So the next 2 chapter, right, is the important chapter in this course. 最重要的 chapter 这个 course 里面，而且是最好玩、最重要、最有趣的，就是 partial differential 和multiple integral， 就这2课吧。OK， 真的是这一课的这一个 course 的精华，这2课。Okay, so make sure you listen carefully, and then if you have any idea pops out in your mind, please feel free to try it out. Okay，告诉我们你想什么。Okay. So let's continue with some function. So for example, let's look at this example here. try and find the domain and range of fxy equals to 1/3. Okay, so when we talk about domain, right? So we will talk about where this function makes sense. Okay, so where do we want this function to be? This function is going from where to where? What's the domain and codomain for this function? I think so. Wait. This function is going from what space to what space? What do you want to be? What do you want it to be? 从什么空间去什么空间？这个 function R 几 R2 to R. Okay, good. Okay, because you will evaluate a number out of these two variables. So, right, so you have a square root function. Where does the square root function make sense in real number? You need to make sure that what it evaluates is greater than 1. Greater than 0. So, you need to make sure that everything inside the square root have to be greater or equal to 0. All right. So can you do simplification of this inequality or not? 叫什么？烤箱，冲箱啊。OK， 冲箱来。Can you do simplification? 这样。OK， so 怎么放啊？我想一下。So maybe 放其他的过去。Remove all the minus sign. And then can you do? That's all. But we cannot get rid of the coefficient, huh? But you guys learn something about eclipse or equation or eclipse or what? Does this look like an eclipse or not? How to make it an eclipse function equation?除以36, right? And then, is it enough to see eclipse or not? You mean right into a square form, is it? Something like this. And is it enough? Enough or not? 诶，其他人有反应吗？有在想吗？啊 ，eclipse equation，什么 algebra and analytic geometry 有学吗 ？eclipse equation 长怎样？哦，你说那个 eclipse 啊，但是它 equation 呢？What's the general form？不会的话就 Google 一下，我也是在 Google。X square over x square plus y square over b square. Okay, do we get this form or not? 我们有没有拿到 ？Right， 我们拿到这个 form 了 ，right？ So 它的 A and B tells you what? Actually, A and B got information, right? A and B should tell you something about what? So A tells you the focal length, is it? And then B tells you no， 不是啊，所以是什么 ？A and B 有告诉你什么？ 不是 measure axis 跟 minor axis。Should I draw first? Let me draw first. So where's the major axis and minor axis? So at eclipse, basically you have two focal point, right? Okay, so how you draw your major and minor? Sorry. Should remove this one. So where you get your A and B? Huh? Oh, 你要 oh, okay, sure. So why you choose the vertical one versus against the horizontal one? How you decide among the two? If 下面的号码 what? What's 下面的号码? You mean the denominator? Oh, okay. Okay, cool. Okay, good. So wait. So what's the general form? Let's write the general form. Oh, over 2 general form A squared plus B squared. Once. So if what did you say? B equals to A, huh? You choose the vertical one. Okay, and then can B and A tell something about this picture or not? Can you construct this equation based on this equation? 讲啊，错也不要紧，什么叫长轴短轴 ？Okay, so you join the two focal points. Okay, and then how about this focal point here? You draw this up. You sure? Okay, and then 来一个一个来，不要紧张，有机会。来，然后 2B. Okay, so this line should be 2B, and then okay, wait. So you mean you pick a middle point and you draw a vertical perpendicular line like this, and then this length is 2A. Okay. Okay. How about others? Did you recall your knowledge? Is it correct? Correct. Okay. Okay. So make sure we go back and check whether this is correct or not. So if this is correct, right? So this just tells you what happens. Right? Just this tells you what happens when this inequality equals to 1. How about greater than 1? Less than 1, sorry. Less than 1. Where are all the other points? So, well, I mean, to satisfy this inequality, what do you need? You need two kind of point, right? You need the eclipse point, and you also need point that is where the sum is less than 1. Okay, so which part the sum will be less than 1? Outside or inside? Inside. Okay, so you should take everything inside here. Okay, like last time what we say, right? If you're not sure, what do you need to do? You need to test the. Okay, if you test the point, you will see. Okay, so this is the domain, natural domain. Right. So how about range? How do you work out the range? How do you work out the range? What is range? What is the range of a function? What is the range of a function? Range 的英文字你知道是什么吗？白单词。 I mean 怎么形容 range？如果是英文吧，纯粹英范围 good very good 范围。So this is a range of function. So function 的范围去哪里找？Where does the range of function live? Domain or codomain? Codomain. Okay. So in this case here, what's the range of this function? Okay. The range of this function. Okay, let's give a name to this range. So this range should live in your codomain here. Okay. So how do we define range? These are all the fxy such that your xy live inside your domain. Okay, so let's call this domain df. Okay, so meaning if you evaluate all these eclipse point, where your value will be. Okay, where's your value? So do you know how to do it? So what's the technique of doing it? So you should make use of the condition you had on your domain here. So these are all the point that set these are all the point inside the eclipse that satisfy the equation. The equation that all the points inside the eclipse satisfy. Okay. So not that all xy in df satisfy x square, sorry, 36 minus 9x square minus 4y square greater than 0. Okay. But we know that fxy is equals to 1 over 3 of what? The square root of 36. Okay. So if we know something about this number inside the square root, can you compute everything inside here? Okay, so so let's move this down a bit. So what's the difference between this and the point that satisfied by the points? Sorry, what's the relation between this expression and the f expression here? What's the difference? So you need to take square root and then multiply by a scalar. Okay. So do you know that if you have a positive number, after you take the square root, you are still positive? Okay. And if you have a positive number, you multiply by a positive constant, you are still positive. Okay. I wouldn't say positive because you have 0 point, so meaning it is not negative. So meaning what? The value of f here should be non-negative. Negative. Right. Okay. Do we have extra condition here? Extra restriction or not? Do you have any extra restriction here? Do you have any extra restriction? 听得懂在问什么？就是说除了这个条件，我们有其他的限制吗？我们都没有。确定？有从哪里找？
后面两项都是减一个正数乘程式，所以一直减，所以上面36减9x² 减4y² 一定会小于这样的。
Ah, so Bumping say that there's an extra condition here. This 36 minus 9x squared minus 4y squared here should be less than or equal to 36 as well. Okay, why? Why is it true? So just now he argued that, what did he argue? This x squared and y squared here should be positive. Okay, so if you're gonna take away positive number from 36, so this value here is at most 36. Okay, so actually there's a upper bound here, not just lower bound. Understand or not? Okay, so how about this condition here will give us? So if we play around with this inequality again, what do we get? First, we get square root first. Okay, and then we take 1/3 of this square root. So in the end, what do we get here? So what we really get is, we also get that fx is actually less than or equals to 6 divided by 3, 2. Yeah, any question? Any question? So maybe I put n here. And then this will imply that my fx is negative 2. Okay. Yeah, any questions so far? 有问题吗？那其他人有没有反应啊？哎，有没有反应啊？你们要像 baby 这样子啊，肚子饿了要哭了，不会你就要哭，OK，不然的话我不知道发生什么事情。如果有问题，你需要问，问吧，没有事情啊。大于我什么讲的都是对的，你就问吧，可以吧？会不会很炸裂啊？这样子教你们，你觉得这样的教育很炸裂？小帅也在想，对，合理吧？会写 fx 啊，纯粹写错吧？对啊，这种问题可以问的，没有问题啊，纯粹写错吧？也不要想这样久，没有，我只是纯粹写错吧，写漏掉了。对，OK，现在 OK 吗？开心吗？不要开心了哈。Yeah，I mean，没有问题了，你就直接提出来吧，不要以为我全部写的东西都是对的，我也是人来的，我是会错的，我又不是神。OK，还有吗？还有其他问题吗？那里玩的东西，那里玩的东西啊？哦，right，对，没有错，对，谢谢，对，没有错。OK，Yeah，feel free to point out。还有嘞？还有吗？OK，OK，OK，好。So be careful when you do this question check if you have an upper bound or lower bound. for these condition to hold. Right. So do you know what's this picture to be? You know what this picture should be? 那这照片会长怎样呢？可能你的 note 里面有了。Right. So let's draw it. So just now follow your suggestion. We have this eclipse here. Okay. And how about the graph? Okay, so last time I said, what did I say here? So function from R2 to R. Where should the graph live? Where should the graph live? Where should this kind of graph live? Live in what space? R2 not enough. So it's not enough. R2 is not enough. What do you need? Graph of F should live in where? Hi, Tyler. Graph of F 的定义是什么？I mean, where should this graph live? Graph of F. Graph 的定义是什么？很重要啊，很重要啊，定义很重要啊。So what's this definition here? All the tuple where you collect all the domain point and your codomain point. Okay, so in this case here, what's the tuple here? This is a 3 tuple here. Okay, so this graph should live in R3. Okay, remember or not? I mean the very simple example from calculus 1. How do you draw the graph? You usually draw graph like this, right? Why you draw graph like this? Because your function is going from R to R. So why you draw an R2? Because you combine the domain and your codomain together. So there are 2R. Okay, in our case here, we from R2 to R. So meaning if I combine my domain and codomain, my space become R3. Okay, still remember I told you how to think about this function from R2 to R. No? Every point in R2, I give what do I give? A height. Okay, I give a height. So in this case here, this function here will tell me the height for all the points within the eclipse. Okay, so for all the points within the eclipse. Okay. So I mean, if you just look at this function here, right? Just now, Boon Ping suggested what? Where's the highest point? Where can you get the most 36 from this number inside the square root here? When x and y equals to what? 0. Okay, when you take nothing from 36. So at 0, it is the highest point, which is exactly 2. Okay, so for the origin here, right, you have the height 2. And then imagine away from this point, what happened to your function? You are taking away x squared plus y squared. So meaning the height will gradually decrease. Okay, gradually decrease. Okay, decrease until where? Look at this boundary point here. What does this boundary point satisfy? Where 36 minus 9x squared minus 4y squared is equal to 0. But when this thing inside here is 0, what happened to your f? It is 0. So meaning your height get decreased until you get zero value on the eclipse point here. Okay, does it make sense? So well, I'll claim that this is What's this called? What's the 3D eclipse? Is there a name for it? Usually the ball we call sphere, right? Ellipsoid. Correct. Good. Very good. So ellipsoid. So you can see that it is like ellipsoid, but how do you determine whether it's an ellipsoid? Later we'll use a partial derivative. Okay. To see how the how curvy is the and how it changes. Right. All right. So in this case here, let's do this question. I'll let you do. Give you 3 minutes and try do this question. Let's see what shape you get from this question. Okay. Who finished? Zach? Okay. So how do you start? How do you find the domain? Your F? I hear that. It's x minus y squared equal to 0. Okay. So I think this is the only um condition we need, right? To make sure this square root is well defined. This should be in R2 again. Okay, because we take in two variables here. And we make sure that these xy will satisfy this inequality. So what does this have effect on our range? Does it have any effect on our range or not? Which end? Does this have effect on our range? I mean, in other words, what's our range? Okay, first of all, where should my range live in? Is a subset of what? how should I write my range? Where my range live in? What's this? I mean, where should I pick my element from? Let me put Z. First of all, where should this range live in? Domain or codomain? Codomain. So what's our codomain? From R2 to where? This is a function from R2 to R. Okay, why is it R? Because if you put two real number inside here, this formula will give you a real number. Okay, so that's why it's the R2 to R here. Okay. But do you reach everything inside R or not? You reach everything inside R? No. Okay, so what's the restriction here? The restriction should come from your domain. Okay, so you already know that this number here have to be strictly or equal to R, strictly greater or equal to R. This implies what? The square root of this number is also strictly greater or equal to R, greater to 0. Okay. So are you done? Can you reach everything positive or not? No. Why? 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 X square and y square are non-negative, and then so okay. There's an upper bound for your 9 minus x square minus y square here. Okay, because you are taking away positive number. Okay. And what does this have impact to? So what you will get is the square root of 9 minus x square minus y square here will be less than square root 9, which is 3. That's now equal to. Okay. Hey, do you have a question in mind actually? Would you ask if I take square root, why don't have plus minus 3 here? Would you ask this question? Or you're happy for taking 3? Usually if there's a square root, you need to ask about plus and minus sign, right? Hmm? 你知道我在问我？对，为什么？平时那个 square root 加减从哪里来的到底？有and then okay. 差不多。So when you want to consider plus minus square root, the question you ask there is different. You are asking what number gets squared to 9, for example. Okay, so let me give you the question first. So usually you want to solve this question here, and then you say that x equals to plus minus square root 9. Okay, so the question you ask there is what number square to 9? So there you will need to include plus or minus, because both plus and minus will square to a positive number, same positive number. So one question you are solving the non-injective function here. This function is solving this injective function here. Okay, you are looking at the square root function here. Okay, here you are solving, let's say here is a z squared. Okay, so here this quadratic function here is not injective, but the square root function here should be injective. So there's only one answer you get. This is how we define square root function. Does it make sense? So you need to be careful when you take this square root thingy. Are you asking a question on z squared or are you asking a question on square root z? Yeah. Right. So what's this picture here? What's this picture here? So first you draw your domain. This domain is relatively easy to draw, right? So where's the part? So like what I told you last time, when you want to draw this inequality here, you should start with the equality. Okay, so if you make this an equality, what do you get? What's the equation you get here? What's the equation you get if you make this inequality or equality? 懂我在问什么吗？不懂。OK，先懂我在问什么，再想讲解啊。最重要是懂我在问什么，不然你解不到问题。So what I want to ask is, if you make this inequality here into an equality, okay, what kind of equation you get? 懂我在问什么吗？重复一下。没有错。然后这个 equation 会变什么？变出来。equality 的意思是什么 ？equation 9减 x square 减 y square 等于 OK。我想得出这个东西是什么？ OK， 认识这个 equation 吗 ？Good, very good. Circle with what? To talk about circle, we need two things, right? Radius and center. So what's the radius and center of the circle? 9. Done. Okay, so okay. Wait. So let me write first. And so okay. So the curve 9 minus x squared minus y squared is a circle with radius 3, center at where? Center at 哪里 ？Okay, so I think 大家要有一个 general form 的概念。So general form is x minus a squared plus x minus b squared equals to r squared. Like this. Okay, where this is this equation is centered at AB and with radius r. Okay, so in this case here is not shifted. So this is centered at the origin. Okay. Right. So but we need to include everything inside less than or equal to 0, right? So meaning what's our df here? Let's draw a df. So y here. Then we have circle df here. Right. Okay. So since our graph is from R2 to R, we need to give all the height. So how to give all the height here? So what's this height? We just take fxy to be square root of 9 minus x squared minus y squared. So what is the highest point here? Give me a highest point. Where's the highest point? Where's the highest point? 3. Where is it? 在哪里？那个点。0, 0, right? And the origin, okay? And then this origin here will have a height 3. Okay. And then what happens if you move away from the origin? X squared and y squared will be positive already. That should be positive. Okay, meaning what? This difference here will become smaller and smaller if you move away from the origin. Can you imagine or not? If you move away from the origin, this x and y will increase. So that this difference here will be okay. So in other words, if I rewrite this, f here as 9 minus x squared plus y squared. What is x squared plus y squared? Actually, it is the length of the, or maybe you can call it vector. Okay, so if you move further away from the origin, meaning what? Your length will increase. So if the length increase, the difference here will decrease. Decrease to the point that when you reach to this circle here, what's your value of f? You will get 0. Why? Because on this circle here, your x squared plus y squared is exactly equal to the radius squared, which is 9. 9 minus 9 is 0. Okay, so you will get the nice upper hemisphere here. Okay, you get a nice upper hemisphere. Okay, okay. We'll learn more about this shape when we study gradient later, the derivative. Okay, we will use the derivative to construct our surface. But these are the basic shape you have seen before. You should have seen right in the algebra course. Algebra geometry course. Okay. Any questions so far? 有问题吗？没问题。Clear? Okay, so if I hand you any random R squared to R function, you should ask yourself, is there any restriction from the function such that your domain need to be restricted? And then if it's restricted, how does it affect your range? Okay. And then from these, you can try and draw your function. Okay. Your function using the graph. Okay. Any last question before we take a break? Yeah. 有问题吗？可以问一些想法问题啊，不一定要是算法。还有些概念也不是很清楚。为什么我要这样子做？为什么我要这样子想？为什么要考虑这个？为什么要考虑那个？可以问的，没问题的。Why the domain didn't have the upper bound? Okay, so let's see. What do you mean by domain has an upper bound? What do you mean by domain has upper bound? So well, I mean, what do you? Okay, 我可能知道你要问什么，但是要把它做 precise 一点。You're asking whether should I put some upper bound here? Yeah. Okay, but this is not mean by bounding the domain, you know. Because if you want to bound the domain, you need to write something like this. Okay, let me move a bit. Move all the other stuff away. If you want to bound your domain, what do you want to bound here? Actually, you need to create some bound like this. Something like that, maybe. This is what called by bounding your domain. Okay, so this one is just an example of bounding the domain. Because your domain is in R2. Okay, but just now our range is in R, so that's why we can write bound in one inequality only. I mean, only bounding one variable. But if you want to bound your domain, you want to bound two variable. Is this the question you want to ask? Or you want to bound something like this? Okay, so did you recognize that these two are different questions? Okay, so these two are different questions. But somehow, if you introduce this inequality here, it also provide a bound. Correct or not? It also provide a bound. How does it provide a bound? The technique I teach you is draw the equality here first, and then decide where's the inequality point living. Okay, so well, let's start it first. Let's start it. So if you draw the point where this is equal, you will get circle like which he said just now, right? But how you decide which part is less than zero, which part is greater than zero? What do? I ask you to test value. I don't know, I ask you to test value. Okay, so for example, you know that inside this circle, there's a point called what? Called the origin. Okay, so there's a point called the origin. So if you sub this origin into this expression here, so you ask yourself, is it greater than zero, less than zero, or equal to zero? Okay, so if you sub it in, you really get a 9 here, but 9 is greater than zero. Okay, so if you try and check more point inside here, actually all those points inside here is greater than zero. Okay, for the moment, we didn't introduce some systematic way to check all points. But for the purpose of this course, if you check some point is greater than zero, it should be all the point around it should be greater. Okay. But Isaac says whether can we add this kind of condition into the domain or not? Can we? If I add this condition into the domain, what happened to this domain? What will happen to this domain here? Think about it. 假设我们加了这个 extra 的9进去，是吗？现在问这个问题吗 ？OK， 发生什么事情啊？Huh? What happened? Actually, something very interesting happened, you know. Something very interesting. 再讲一次，是往这。S square plus y square is greater equal to 0。这个是什么点来的？什么点会符合这个条件呢？全部了。所以 meaning what? You change your domain already. You change your domain into what? The whole plane. 变大了，反而变大，变成整个 R2 了。如果 add 的话 right. I mean, if we just discuss on this side here, okay, if we just discuss on this side here, it is the whole R2. But if you include these two, meaning what? You need to take points that satisfy the both two inequality here. So you still get back your circle. Okay, so it is quite unnecessary. Okay. Unnecessary. But what I want to show you is it will change your domain. Okay, if you add different bound. OK， 没问题吗？大家懂怎样 get 到这个吗？对吗？会啊，9大于等于9减 x square minus y square，and then you cancel 9 and then you multiply minus. So you swap the inequality. And then what sort of number can satisfy this greater or equal to 0? Basically all points. 0 also satisfy, and then all negative positive point also. Okay. So if you add this into it, basically what you get is, let me just quickly draw it. So it's just R2 intersect with your circle. So basically it's your circle again. And then what happened? You mean equal to 10? Okay, and then, so what is this? This is x squared plus y squared equals to -1. So is there any xy that satisfy this equation or not? Oh, why? Because on the left-hand side is always positive. What do you mean? What do you mean? What do you mean? Hmm? What?
Maybe fxy equals the square root of 10.
Right. So you want to ask a question whether this value will hit square root 10 or not. So I show you that it is impossible. Okay, I show you that it's impossible. So where's square root 10? I mean, no, shouldn't be complex, right? Square root 10 is just an irrational number. I mean, what's the decimal expansion of square root 10? 3点多, right? What is how a graph looks like? Our graph only can reach value 3 at most. So above 3 point something, we won't achieve one. Won't achieve. Does it make sense? We won't achieve that point. The highest point of this sphere is 3 on the value. Okay, 3 point something rather than 3, you won't achieve it. There's no point with that height. And then you can show it algebraically. Look. This is how I show it algebraically. Because you cannot solve x squared plus y squared equals to -1. Because one side is positive, the other side is negative. Really? Positive number is not equal to a negative. Yeah. 还有吗？还有问题吗？ Okay. Yeah. Yeah, good. Okay, so let's take a break until 10:20. 做 WPP 了，你都我帮你上个课，对吧？还有我们做 LA 啦，还有我今天上12点的 WPP，
对，
做那个
yes，这个可能我不知道，老板他们比较讲。
这个是运动方面的，对，这样如果我用它的话，我要去补。
不用
不用，
代板上讲的东西全部可以。
他说还有一个问题就是，
对，
等一下，电脑里面有这个，我直接我可以做这个 project 来
哦，你要找这个资料哈。
interesting 的 if 你serious 然后我找到这个
OK，
这是17世纪的时候一个数学问题，我想
best problem 啊。
对，
OK，
我想说可以用高估的读的内容去 prove 这个，
可以，好，可以，
然后之后我再找点资料，
可以
，OK，
，OK。 Have you decide your project one topics? Yeah. What do you want to do? 等一下，等一下，还是等一下？OK OK。嗯，告诉我还有今天稿子啊，OK。一起嘞？OK，结束。OK，break 的时候或者结束哦，这样可以吧？他没有在今天，一想他在哪里？他去哪里？不，所以不行啊，没有遇过他是不行的。啊，什么咱们就今晚那个别克哦沙发啊，对了，一直讲几点呢？哦，下午的。Ampo, have you decided a project？几时要 decide 啊？明天，明天啊，OK，weekend 给我啊。小莹有小莹，哎，小莹今天没有在啊，小莹没有在。小杨，小杨呢？你要 project one 跟我说，告诉我了吗？你要 project one 决定题目了吗？什么时候决定？这周要决定吗？啊，周末一定要给我知道，知道从哪里选吗？班上那些建议啊，或者你如果有一些什么想法，也在。今年呢？今年 project one 的题目还没有，知道几时要给我知道吗？啊，这周啊，周末啊，一定要给我知道啊，不然再拖不下去了啊。Okay. Right. So just now I just tell you how the value increase or decrease, and then you try and guess what your shape is, right? So we will gradually introduce more tools, again, for you to decide how your actual geometry looks like. So the next tool we're gonna introduce is called the level curve here. Okay, level curve. So what's the level curve here? So I'll tell you what's the definition first, and then I'll tell you why they name it like this. Okay. So first of all, this level curve is what? Is another function. I use a function. Function from where to where? Function from R2 to R also. Yes. Okay. So what's this R here? This R here is very special. I will call it K. Yeah, we call it K. K is a what? Is a fixed number, constant. Okay. And then the collection, if you put different K, put all, if you, okay, you start with a, sorry. So let's start with a R2 to R function first. Okay. And then you compute for any R. Okay, what's your XY? So, sorry, I think I'm a bit stupid here. So so let me write down the equation form. So what's the level curve of F Okay, so let me be precise. Level curve of f at k. What is this? This is a point in R2 that satisfies fxy equals to k. Okay, so this is a level curve at k. So whenever we talk about level curve, I need to tell you which level is it. So this level is level k. 有概念吗？第几楼？你现在在几楼？几楼？啊，居楼，对，不要3楼，吓死我！我们在居楼哎，我感觉我没有搭电梯搭这样高啊。Okay, so G low, right? So here is a level G. Okay, so if you collect all these level together, this is what we call a contour map, contour plot or contour map. Okay, so these are the collection of all curves. So all the level curves. Okay, so for all K. Okay or not? So you see, contour plot is a set of set. Inside these elements is bunch of things. Okay, so every element here is a level. So how to imagine this? So if you have a picture here, right, what can you see? So here, so this is what? This is actually drawn as a graph of f. Okay, so this is a graph. So how this graph looks like? Where's the domain and codomain? Can you straight away determine from this picture what is the domain and codomain? Where's the domain? The domain is the outer circle here. Okay, and then what's the range here? The range is this UFO thing. Okay, so the range is from, let's say, where the top one is 45, and then bottom one is, did it tell you about? I'll see clearer. Okay, so this is a 40, and then the bottom one is actually 20. Okay, how do I see this? You can see from this K here. Okay, did you see all the K here? So there are how many K here? 1, 2, 3, 4, 5, 6. So there are at least 6K here. Okay, so K1, K2, K3, K4, K5, K6. Okay, and then where is the level curve? How should you imagine the level curve? So you should imagine a plane. Okay, so imagine a plane with height k. So how do we put this? So in our third variable is z equals to k. Okay, intercept with the graph. Okay, we have a graph of f. Okay. Imagine a plane with z equals to k, intercept with the graph of f. Then this intersection produces the level curve of f at k. Okay, at the level k. How about we put level k at level k? Okay, does it make sense? So if we start with this curve here, so you ask what's the level curve at k equals, for example, 30. Okay, where's the level curve at k equals 30? What do? You take the plane z equals to 30, and then you intersect with your graph here. Can you see that if you intersect with your graph here, what you get is just a circle. Okay, in this case. Later we'll see example, but in this case, you will see a circle. Okay. Yeah, so that's why it is called a curve now. Okay, because what you cut out is a curve. So if you imagine if you go higher dimension, for example, if you involve x, y, z, then your dimension will increase. Okay, maybe that time we call it level surface, and then go higher and higher dimension. Okay, But the level here is correspond to if you take the plane z equals to k, and then you intersect with your graph here. What's the shape you get? What's the curve you get? Okay, what's the geometry you get? Okay, does it make sense? Okay, so basically you are collecting all the points, okay, in your domain that satisfy fxy equals to k. So you need to solve it. OK， 好，感觉有点抽象哦。等一下我们会做一点例子。I mean, did you learn geography? Geography? You learn geography. Okay. So if you learn geography, you will see this kind of map for your mountain. Okay. So how to see this map? Okay, come on. 什么？什么东西？说什么？好的，来看到这里。So what is this geography here? How do you see this geography? First of all, you draw out roughly the shape of your mountain. But what are these lines representing? What are these lines representing? The height, yes, exactly the height. So what are we doing here is I give you this map, right? You should imagine a mountain in front of you already. 你明白吗？他画一个25的东西，你应该要想象有一座山在你前面。怎么想象啊？ You know how to do it? You just follow the height that the contour give you, and then you lift that shape up. 看看谁高谁低，谁高谁低。Then you will reconstruct the mountain in front of you. Can you imagine? So here basically it's just one mountain because going from inside here 5,500 and then you keep going down. So it's just one mountain. Maybe in general you have up, down, up, down, up, down. Okay. Okay, let's do some quick example here. So I'll try to sketch the level curve of the function 6 minus 3x minus 2y. 有人对这个function 有想法吗？首先，大家认识它吗 ？Algebra 里面有看过它吗 ？Algebra geometry. One variable, one linear variable in 2 dimensional. 它是一个什么东西啊 ？Plane. Okay, it should be a plane. OK， 等一下我们会用 level curve 来看为什么它是一个 plane。OK， 有吗？有印象吗？如果我换成 z 等于6减 3x minus 2y 是个 plane。OK， 有看过吗 ？Basic shape。OK， later we'll use a level curve to see why is it a plane also. Alright, so now let's compute the level curve now. So meaning you want to intersect this curve with the plane at z equals to minus 6, 0, 6, and 12. 这些分别是什么 plane 啊？一个是在 xy plane， and then xy plane 下面 minus 6, xy point 上面6，还有一个 12。Okay. Right. So let's solve it. So what are these curves? So let's solve it. So if we consider so at k equals to minus 6, what's your function? What's your level curve? What's the curve that satisfies this function here? What's this curve here? This curve is 怎么算？有人会算吗？ Okay, what's this? What sort of point that satisfies this equation here? Y equals to, maybe we move it into a form of y equals to ms plus c. So what's the gradient here? 来，小鹏，来等我，等你，有算错吗？算错来，然后想下 I think 这个忘记换 ，and then 我 move 去另外一 side 嘛。哎，对，打了。Okay, so what's the gradient and the y-intercept here? 小鹏，没懂。Oh, I mean, right. Okay, sure. 没懂。Okay, good. So I think we need to create some common language here. So if you look at these y equation involving just a linear form, right? You should be able to turn this into a form of y equals to mx plus c. Because y equals to mx plus c is what? It's just a linear graph. With what? With the gradient m and with the y-intercept c. So that's why we like this form. This form will tell us what is the gradient, what is the intercept. And then this is the basically two things you need to plot your graph. Okay. So in this case here, what's your gradient? And what's your y-intercept? Minus 3 over, wait, let me think. Minus 3 over 2, good. Okay, so what's your y-intercept? 6. Okay, good. So can you plot this up? So where is this? Where is this curve here? Y equals to minus 3x plus 6. So you should start with a negative x first, right? And then you move out by 6. Okay, you should intersect at 6. So we call this line, so let's say this is the line we want. Y equals to minus 3 over 2x plus 6. Such that when it intersect at y, what do you get? You get 6. Okay, let's extend this a bit. Okay, let's call this line we want. Okay, and then you continue the game. Okay, check all the height. Check all the height. So what happened at k equals 0? Okay, I let you do all the other points. So do it together. So check what's the line you get when k equals 0, 6, and 12. 来，一个一个 check. What's the line you get? I'll give you 2 minutes. Try and compute what are these lines you get. Okay. Let's get 1 more minute. Okay. So Chuanyi, you know what line do you get if you take k equals 0? Mm-hmm. Mm-hmm. Plus 3. Okay, good. Let's get another table. 一平是吗？一平在吗？ Okay, what line do you get when k equals 6? That's all. So your y-intercept is 0. Okay, good. Yeah. 余后呢？对不对？ Okay. K equals to 12. What line do you get? Minus 3. Okay. So what did you observe here? All these lines have the same gradient, but with different y-intercept. Okay, but with different y-intercept. So these are plotted out here. So how do you interpret this level curve here? What do you do? What do you do? So this height, this k here, will tells you how tall is it in the graph. Okay, so meaning how should you imagine this? Let me draw. Let me draw out the 3-dimensional space here. So we have x y in this case. Okay, and then there's a z here, right? So where's this k equals to -6 here? So you have how many level? Okay, so let's pull out our level. So we have -6, 0, and then we keep continue up. So let's continue up. We have 6, and then we have 12 here. Right. So let's get the first one. Y equals to -3/2x plus 6. So it's around here. So we move it maybe here. Okay. So this line here is at which level? It's at the -6 level here. So let's draw this -6. Okay. But when k equals 0, what is it? Okay. So I mean, how should I draw this better? Let me think. I think, well, I mean, how about we throw this away? Let's throw this the xy plane. And then when the height 0, k equals 0, where's this level curve? This level curve move in a little bit. Okay, because the y-intercept become smaller, right? Getting from 6 to 3. Okay. And then when you go higher again, what did you see? You see that your y-intercept getting smaller also. So let me think, how should I draw this properly? Is okay. And then how about k equals to 12? Where is the intersection here? The intersection here become negative. So you move further to the left. Okay. Can you see like a staircase? Imagine a staircase. So if you calculate more number in between these level curve, you'll see all the straight line with different height. Okay. Basically, what is this? If you join them together, this is just a plane. Okay, so if you join all these together, it is a plane. In particular, it is a slanted plane. Okay, 斜的 plane. That's slanted. Okay, okay. Right. Let's look at another example here. How about this one? 这个刚才我们画过了嘛，对不对 ？Square root 9减 x square minus y square here. But if you compute all these level curve, let's quickly compute this. If you compute all the level curve for 0, 1, 2, 3, 4, what do you get? You get a circle with different radius. Okay, you get circle with different radius. In particular, what kind of radius you get here? Particular, what kind of radius you get? So the first one, the circle we get is very familiar. It's the radius 3 circle. For second one, Ping Xiong, what's the radius we get here? Square root become division. So what's the square root? What's the huh? 2 square root 2. Okay, okay, good. 2 square root of 2 square. Okay, and then how about next level? What circle you get? So yeah, Jingsen. What's the radius you get? Square root of 7, good. And then you can see that the radius becomes smaller and smaller. 懂吗？有算错吗？square root 7啊，9减1，9减2不是7吗？哦，对，thank you，thank you. So what do we get? 4, 5, 4, 4, 4, 4. Okay, so I get 4. So we should get 2 square 5还是4 5 OK square root 5 square OK and then 下一个呢 we get 3 which is square root 3 看一下有没有算错339还是0啊？最后一个是0，这个是0。Okay, so what can you see here? Did you see that the radius is decreasing? 2乘 square root 2是什么 ？In decimal point form. 多少？大概多少？啊？2.8 OK, good. Square root 5呢？2.2 right? So you can see that when my level go higher, what happened to my circle? Become smaller and smaller radius. Correct or not? Just now, what picture we draw just now? It is a hemisphere. So if you cut at different level, when the level go up, what happens? The circle becomes smaller until when you reach the radius 3, what do you get? You get exactly 1 point. Exactly 1 point. No? Only 1 point can satisfy x squared plus y squared equals 0, right? Only 0, 0. Does it make sense? OK 吗？所以我们是把那个几何拆分来看，可以用一层一层来看。So that's why we call it level curve. 这一层应该是什么东西？下一层是什么？然后我们把这一层贴在一起。OK, good. So I mean, well, 要怎么真的具体去画这个东西啊 ？What do you do? You really can put this circle stack up, right or not? So when k equals to 0, you have this full circle, and then when you gradually go up, what happens? The circle gets smaller, smaller, and smaller until you reach a single point at the top. Okay, ma? So you join all these together, where you get a semi what? Hemisphere. 诶，这个会熟悉吗？这个图片我感觉我很熟悉啊。小时候有玩过这个玩具嘛？然后圆圈啊，一圈一圈一圈，越来越小，越来越小，然后跳，有玩过吗？没有玩过，去那个儿童的部分看一下这个玩具，很有趣的。OK，所以啊，你要你的孩子数学好，不是也要玩多一点玩具？有啊，
没有
玩 LEGO 啊，LEGO 是其中一个，这个也是吗？你们那种好像套圈圈的那个丢了，它会套上去的，但是这个是有很多个，越来越小，越来越小。啊，如果有机会，我拍给你们看，我拍给你们看这个玩具啊，我朋友的孩子，我拍给你们看。OK，这个玩具，right，玩玩具很好的，训练你孩子的思维，他就不会一直哭了。Okay, right. So, let me give you some generalization of dimension. So, how do we get higher dimension objects here? So, we start with a 0-dimensional, which is a point. Okay, just now you can see that we have point. But how to form a line? 怎样 form a line? Actually, you use out infinitely many points together. Okay, until you get a line. 可以想象吗？ Okay, but how do you make a plane? Okay, how do you make a plane? So what you are doing is you can slice it into lines. Okay, actually there are two ways to slice it, right? You can either slice it a horizontal way, or you also can slice it in a vertical way. Okay, so there are choices here. 你可以选择的，其实你也可以 slice 它斜斜的嘛，对不对？也可以。有呢？Okay, 有点 太快了。Okay, so there are few ways to do it. Actually, there are infinitely many ways, but these are the basic shape. But how to go three-dimensional? Imagine you got a parcel. 你们每次有去107买东西不是？拿东西 I mean. So how to get a box? So you can put a bunch of square together. Okay, so you can put a bunch of square together. You can wait. Wait. Okay, so you can put a bunch of square together. OK，所以这种空间的拆分能力啊是很重要，对于这个课，对于这个 vector calculus 里边。OK，你要一直拆分你的 spaces。OK，每个人有自己的想法或者自己的喜好去拆分，is OK，as long as 你可以算到同样的东西。OK，so you need to develop your intuition to divide out your spaces. Okay, so let's give some more contour for you to see. Okay, what can you see here? So if you look at this function, let's make it bigger. This seemingly complex function here, minus xy times exponential to minus x squared minus y squared here. And you can get these contour. Okay, this control doesn't tell you the height yet. Okay, 没有告诉你高度，只是告诉你有这个level curve 罢了。所以它高度在哪里？ So here is the height. Okay, what can you see here? Basically, what you see is for the K on this first quadrant and the third quadrant here is positive, from 0 to positive. So that's why it grow up. But if you look at the second quadrant and the fourth quadrant here, the K here should be non-positive. So that's why the height here is going below. Okay, going below. Okay, so let me point out here. So here K non-negative. Here also K non-negative. And then the other two side is K non-positive. Am I correct or not? Oh, I swap again. So XY correspond to this one, right? So XY correspond to this. But this is negative, so I think we need to swap. Okay. Yeah. Okay. Right. Can you relate these this shape here to the level curve here? So if you take a plane, okay, plane and level K, intersect this curve, what do you get? You get some sort of a circle. But when you go downwards, it's look less like a circle. 有问题吗？看得懂吗？这个图 ，OK 啊。It doesn't specify K here, so you can't really get information of K from this level curve. But if you look at these actual graph, you can try to infer what's the K on this quadrant. Okay. Similar for this. Okay, you can see that this is like a spider, looks like a spider, right? But if you put different K, you can see that in the actual curve, on one side, it is growing upward. On the other side, it's dented. Okay, I was actually. Okay or not? Yeah, I mean, this type of things are quite important in physics. When we see general relativity as a curvature of space-time. So you can imagine there's a very large density sun living here. Right. Hey, do you guys know where you can plot these curve online? You know what things to use? GeoGebra, Desmos also can. MATLAB, yeah. And MATLAB very small, right? The picture produced, very small. You should use GeoGebra or Desmos, yeah. Those two are good. And you can put multiple graphs together. There's another 3D graph. I mean, you just Google it. The best 3D graphs, I mean, the good one should have color because color can help you to differentiate the height. Okay, so you should use those with color. Something like this, got color one. Okay, will help you to differentiate the height. Okay, if no color, it's very hard to see one. Okay, does it make sense? Okay, yeah. So I need to convince you control graph is nice to use because we can use 2D graph only. And then you should create a 3D image in your mind. Just put the height up, 把高度加进去，它就会长出来了，谁高谁低。Then you can imagine this shape. Does it make sense? Okay. So to go from control graph to the actual geometry, I only need to tell you the height. So we only need to know about K, okay, the level, the height, in other words. So the height, the level is referring to the same thing. Okay. Okay, let's continue the last thing and then we will take a break and then we go to limit later. So you, like what I said just now, you can increase your function, your variable in your function, go to 3-dimensional. But if I go to 3-dimensional, like Jingsen again, what's this function from? And what's the codomain? R3 to R2, you sure? R3, you sure? So you add all these x, y together, what thing you get? Just one number, right? Okay, so you get R. So if you're gonna draw this graph, where should this graph live in? 来，再来考玉良. Where should this graph live in? 我东西要加起来。Okay. 现在去哪里 ？The graph of f 要躲在哪里 ？Where's the subset？ 你在哪里画它的 graph？We need to add the domain space and codomain space. So if we add up together, where's the space should be? Not quite. I mean, look at these two. Just look at these two. If I want to add these two spaces together, so what's the spaces? R3 plus R. You get R? R4. Yes. So your graph should draw in R4. Can you draw or not? Cannot, right? What did I told you? Yes, please call me if you can draw it. But today we can draw the level curve. Why? Because the level curve live where? At at k equals at k in real number, where these level curve live in? R3. So 全部符合这个 equation 的 point just live in R3. You can draw the level curve, but you cannot draw the whole graph. Okay, so this is one point why we study level curve. 有时候你可以画 level curve, okay, 但是你画不了整个。Okay. Right. So should we domain 要不要找啊？要不要找 domain？ 看一看。I mean 这个 curve 很丑哎，我们不要找这个了，我们换一题。这题有点难画，不知道讲话是 long 了，又加一个 sin， 太难了，头太痛了。OK， 来画这个，这个 level curve 应该比较容易找。OK， so if I want to find this level curve what do we need to do？ 来选几个号码？要不要选几个号码 ？level curve k 等于几？来 ，Isaac 选一个。今天1号选1号 ，good。还有什么 k？ 来，一座选一个。凯伦。减5哈 ，OK， 我感觉不可能，但是我们先写这边。我们就是要 try 吗？数学就是要 try。来 ，Humble 选一个。哇 ，OK， 好。来，这一座认同。6、0 ，OK，good， 0是不错的选择。0是 almost 每次你们都要选因为这种0、1减1这种号码你要 sensitive 一点。OK， 下一座 恩子哎，来，good。还有嘞，后面那一座虽然没有教到啊，子莹10啊，OK，good，very good。好，你们大家选的不是大家一起算，来算什么 level curve 会符合这些东西。Okay, did everyone got the same level curve here? 有吗？有看到吗？全部。Right. See whether this level curve valid or not. 第一个有可能等于减了吗？有可能吗？有点符合，为什么没有？On the left hand side, the number should be positive. 开屏发了吗？开漏了。开。OK，开了。Right. So first one is impossible. So there's no point at negative level. No point that satisfies negative levels. But starting from K0, it works. So what's this point here? Any point that satisfies this? What's the set of number that satisfies this? Just the origin. Okay, so this is just the origin that satisfies this. How about the others? The others has pattern, right? What are these for general form of what? These are sphere. Okay, sphere with radius what? With radius k. Okay, center at where? At the origin. Okay, so you see that when the level curve grow, the radius also grow. Okay? The radius also grow when the center grow. But if you ask me how to join them together, I'm not sure. Okay, I'm not sure how to join them together. Because to join them, you need to tell me what's the extra variable here. Let's say x, y, z, w. So how I put the w variable will tell me how to join them. Okay, but I don't know how to place the extra variable now. Correct or not? 会吗？会奇，你会不会想问 w 可以这样放吗？如果我是你的话，我会这样吗？可以吗？为什么不可以？为什么不可以这样放啊？我 introduce 一个新的 axis 吗 ？And then 这个 direction 又跟其他不同，不可以这样做。没有 linearly good. It's not linearly independent to x, y, z. This is what you prove in your linear algebra. Okay. Okay. If you take another different direction here, you should be able to break into x, y, and z. Actually, you have a way to do it, right? Yes, you use the inner product, the projection. Yeah, use the projection. Yeah, this is why you learn Grant-Smith or something like that. Okay, you want to break down the extra direction, okay, to the other, to your basis. Okay. So unless you can tell me how the W add into this space, otherwise I don't know how to join them. Okay, otherwise I don't know how to join them. But this picture looks like what? Looks like your Earth, right? 不像你的地球嘛。Okay, so you can draw your Earth by using this level curve. 第几层？对不对？ Okay. Any question before we break? Right. Okay. There's one thing I want to want to clarify here. Maybe you will see, I said level curve, but here put level surfaces. Okay, so what's the difference here? Why curve becomes surface? Because the point that we consider here has one extra variable. Okay, so instead of just drawing curve like just now, what you have is a higher dimensional object, one dimensional more, which is a surface. And then next dimension, we will call general surface called, not surface, general shape called manifold. Okay, we go manifold, level manifold, yeah, n manifold. So when it is level one manifold, we call curve. Two manifold, we call surface. And then three manifold, no name already. And then we just call n manifold. Yeah. So this is difference between curve and surface how you need to learn. So in our course, basically we just deal with curve and surfaces. Okay, curve we call one manifold, and then surface we call two manifold. You know what these one and two correspond to? Curve is like a line, right? Or one dimensional. Surface, surface you can imagine you can walk at least two ways. Okay, you can walk two ways. So it span a R2. 对吗? No, you need you imagine you are an 一只蚂蚁讲话 Okay, you are an ant walking on this like okay 就像现在吧，也不用想你蚂蚁，你就在这边走吧。你觉得这个地球是有一点 curve 吗？有吗？Maybe 从 NASA 看进来会看到远景，但是你在上面走的时候，你不会看到，你会觉得很平，就是 R2 啊。Okay, so this is the concept of manifold. But if you look from outside, you'll see the speed. But if you just walk on here, you will see 哎很平哦，没有弯下去啊，没有哦，不是，对，你就这样走了，很平。Okay, it's like R2. So this is what we say locally R2. 就是你在走的局部走的时候就是 R2. But if you look at the whole thing from outside, actually it's a sphere. So this is the idea of it. 线也是一样，虽然它是一个圆圈，但是你在上面走的时候，你一直看就是一条线嘛。Zero manifold 一个点哦。I mean this is refer to what I draw just now actually 哦，这样子，就是0、1、2、3。OK 吗？那一个啊，那个是蛮 technical 的，你们有 factor dimension， 有一些东西叫 factor geometry， 就有那种 factor 的 dimension。But how to define it is not what you see now. It's use a different definition. So, different definition. It's not maybe it's not the basis you see already. It's a how to get the factor number is a different definition. Okay. Yeah. So the number here basically just refer to the linearly independent basis. Number of linearly independent. Okay. Right, so next up, we will continue with limit, continuity, and then differentiation, and then, yeah, and then maximum, minimum. It's the same story you see in calculus. Okay, basically, you need to define limit, and then talk about continuity, and then talk about derivative. And then after derivative, you need to find what? Maximum, minimum point. The same story go on. But now we increase our dimension. Right, so let's take a break until 11:18.
就这个。对啊，OK
可
OK
以想做之前那个，
OK，
确定吧，反正
不确定这个，有想法，可以吧？可以说这个，可以。但是想跟你说的是，这个其实写的不够 precise，你可能要写一个更 precise 的 definition，就是能够让你计算的 definition。这个只是一个很模糊，就是
在定义
对对对，就可以让你算的。其实你要用什么 for all epsilon 哦，再就是不要它的那个，对吧
OK，
呀，就是二维的 differentiable 啦，简单来说。对呀，好，好。哎，其实我看到那个独立的 calculus one 里面有考 epsilon delta，其实，所以你们全部是会做嘛？这样子，方法论也很好啊，其实，呃，至少有 idea 会算，大概懂。OK，其他的呢？会算吗？当时候出这种题目的时候，还蛮大题的哦，我看到，说一整题都是那个啊，I mean 方法是 OK 啊，但是它有换 function 吗？还是它 function 是一模一样板上给的？不一样，不是？OK，哦，OK，呀，I mean 至少一个 idea 讲算先，然后我们讨论概念的时候比较容易，不然的话不知道在讨论。哦，OK，哦，就是一个从头写到尾，一个从尾写到头的东西。对，我有看到他的答案有这样做。你们那时候考试也是3题，是不是？大概差不多这样。 四题，四大题啊，觉得有时间做得完，我可以做不完。OK，好的，所以已经有做不完的迹象。哦，要不就做不完。OK，如果我的考试的话，不是你就不要想太多，你尽量写吧，你不会停啊，你一停下来几乎就浪费时间了。OK，想到什么就先写先。不要坐在那边一直想，不然就没有时间。想不到先 skip 哦，真的，你先做会做的先。呀，先看完，OK，哪一个会做先做先，然后再想。开始做器械嘛，你们做器械啊，你们要学会用你自己的器械。OK，做习题的时候，做我的 practical exam 的时候，看一下有用到吗？比如说你要做这一题，哪一个 concept 是你不稳的？OK，写进那个器械里面，或者你会忘记的，写进那个器械里面。OK，还有一些特定的方法，maybe 你觉得，哎，我可能当场 recall 不住，写进去。OK，so exact，其实这一部分的为什么有器械这个 design 呢？其实也有一部分是要让你知道你自己需要什么，你要自己去考虑这些因素进去了。嗯，OK 吗？因为大学的话，我们希望考的 concept 是一整块的，就是一大块的，而不是一小块一小块一小块的。那个是中小学在考的那种考试，而且我们现在考试也变了，不是？我们有很多那种 K8题啊，其实就是需要思考的，而不是就一块一块的 knowledge。我们现在是要考 understanding，怎样把东西放在一起。第三题是什么东西？第三题是什么东西？啊哈，啊哈，啊哈。然后什么要画？我有讲要 sketch 嘛？Find an area。对，I mean，OK，I mean 这样子讲啊，我讲一个很 general principle 啊，关于要做一件事情，不要做一件事情，就是说，假设你没有做到一些东西，但是你答案是错的，哎，你没有那个步骤啊，我看不到你怎样错啊，这样我不能够给你 extra 分，你懂我讲什么吗？如果你画一点东西，然后我知道哦，原来你只是画错，那我还给你一点分，明白吗？但是如果你算，OK，他不然答案不对，OK，你做到我要你做的东西，OK，答案会对。但是假设说你今天答案算错，OK，但是你的过程没有写到很仔细，你没有画告诉我哦，其实我要这一个，其实我要那一个，哎，我就不能够给过程分，明白吗？我改考卷的过程分很重要，其实重要过你的答案分，你答案可能算错一点点，不个一两分，那你过程整个没有的话，你几乎就是只有一两分了。你明白我讲什么吗？OK，说过程很重要。OK，呀，过程非常重要，因为过程 basically determine 你怎么去算那个答案。如果过程对的话，你答案就不会错到太离谱，你明白吗？说如果你觉得画对你有帮助，你画了，然后我也可以看到你哦，原来你知道这个是要长这样，哎，我觉得也可以。如果你没有给我过程，但是你答案又错，我就不知道你从哪里来的这个东西。Basically，如果你要跟的话，就跟像我班上讲 present 哦。如果我需要画就画咯，我有呀，这很重要。哎，其实你会觉得哦，我讲的东西好像不讲讲， 规范，我会告诉你你一定要这样这样这样这样这样，但是我每次做的东西都是那样的，所以其实你要跟你就那样跟。OK， 如果即使你不跟，你要懂为什么我要这样做，你明白我讲吗？我很少会讲你一定要这样，你一定要这样除非我去教那种 apply 课就是他不知道他在做什么的，就叫他这样做就对了。真的，以前我教 AI 比如教那种 service course AI 还是 discrete math 一开始我很兴趣，你要这样讲这样讲，后来哇全部 get 不到，这样做就可以了，这样做就可以了，这样做就可以了，这样做就可以了，因为他也不想问为什么这样，对，就是这样的关系了。所以希望我们数学课不是这样的，都数学系的，对不对？所以我们大概就要知道一下，大概知道一下怎样，然后什么东西要注意 ，OK 吗？好，so basically 要从你们自己开始要一直问我会尽量讲，但是有些东西会 miss 掉，对不对？可能有10个东西吧，要在5分钟内讲，那讲得完呢，可能会漏掉一些，或者10个东西里面可能8个东西你懂了，对，那2个东西你就要问哦，所以我就给你机会问了。OK，有些老师不给你机会问的，就他讲的。OK， so let's review this epsilon, limit of a real value function. So I noticed that Dulip will give at least one question on this in the exam. So let's review what is this asking about again. Okay, and then we'll try to generalize to R2, function from R2 to R. So let's start with calculus 1 function from R to R. Okay, so how do you define this notation here? Limit of fx when x go to a is L. 有人会背起来吗？这个没有人背得起来。嗯哼。F F X and A 可以 delta or epsilon delta then OK actually 还有一个 extra 条件，我不需要 check x 等于 a 的时候，因为我只要看 limit 嘛，我看它周围吧 left or right OK and then where do we pick this x this x should come from our domain 什么意思？他去人化，人化这句话讲什么？在 A 的周围多周围撩它的周围 OK so OK 看去人化 let me draw the graph So let's start with a picture. So okay, again teams in this course 这个我们这个课主题一看到这种数学文字把它变成几何，把它变 geometry。OK， 我说 start with a function， 你就 start with a function，start with 一个正常的 function， 不要太怪了，太怪了我们 counter example 来讨论。但是这种情况我们选一个简单的，说简单的 function 嘛，就画一条龙哦。Okay, maybe like that. Okay, and then we want to check at the point A. 选一个 A， 随便选一个。Okay, 选这个 point A. Okay, and then above this point, what do we have? So this whole graph is a F. Okay, let's call it F. And then what is L here? So where should this L be? If the idea of limit says what? 靠近这个 A 的时候，它是一个 limit 叫 L 的地方。所以 let's call this point L. Okay, and then let's call this point L. 我画一下这个 L 点。Okay, and then okay, right. So 把这个 epsilon delta 变成人化怎么说 ？You start with what? Epsilon first. 所以其实你是范围这个先呢，你要保证这件事情先。OK， 为了保证这个事情，怎样画在这个 graph 上面 ？Absolute value 小于 epsilon 的意思是什么？ 它的上下只有 epsilon 的距离，上下就有 epsilon 的距离。So for 每一个这个 region epsilon，okay, for every this kind of region epsilon，what do you need to find？ 找一个 delta 要做什么事情 ？Such that if your x inside your domain is delta close to a, your fx, okay, that's true. Your x and your fx have to live where? Within the epsilon gap here. Okay, in this case here, 找得到这个 delta 吗 ？delta 在哪里？如果我 fix 这个 epsilon，delta 在哪里 ？delta 很高哦，可以选一个最大的嘛？最大的从哪里去哪里？在 A 的周围 ，such that 它的 fx 是躲在这个 epsilon gap 里面。最大从哪里到哪里？你们看得出吗？这里，从哪里？可以选。Okay, how about we make this artificial a bit? So let's moving. Let's it go up. Okay. Okay. So 可以选哪里啊？delta? Where's the first spot you can screw? 从哪里去哪里？来，炳兄，最喜欢问没有讲话的人。哇，有为什么？在哪里 ？OK， 对，这个才是问题，这个问题很重要。这个问题很重要。So I want to find a delta. Okay, so 这个 delta 做什么 ？Such that if the point x minus a is less than delta, so meaning this distance here less than delta, I can make sure that all the fx here is living inside this epsilon gap. OK， 所以可以选多大的 delta。Can I choose here to here? Can, right? Why? Because you see that all the fx here is within, minus L is less than epsilon. Okay. But can I choose here to here, for example? And why? 回旋中不可以啊？为什么？回旋谁 over 哪里 over？ 它后面这里跑出去了，对不对 ？Okay, so you cannot pick this big of epsilon, so you need to pick smaller delta here. Sorry, I mean delta. Okay, but 还有一个情况是哦 we throw out the point at A. So meaning actually we don't care. Actually we don't care what really happened. So let me take a precise laser here. So we really don't care what happened to FA. Okay, we don't care one. 在这个点不 define 都不用紧了，其实。When we talk about limit, we don't care what happened here. 其实它可以跳上去啊。For example, maybe we define a piecewise function. 来这边跳上来。It doesn't affect that the limit is L. 哎，这个点不重要的。Okay, so when is it important 啊 ？After you learn limit in calculus 1，其实这个点很重要。When you want to show continuity. Okay, if this function is continuous and you want to require that L is actually FA， 它要回来。Does it make sense? But if you just talk about limit 啊，不用紧的，在这个点是什么都不用紧。We just care about nearby. Okay, nearby 吧。Limit consider nearby 就好了。Okay， 只有 continuity 你要 make sure that 如果这个 function is continuous and A，you need to make sure that this L here is actually FA. Otherwise, continuous, right? 好到一半断掉，有的 not continuous. Okay. Does it make sense? So this is why limit and continuity has connection. Okay. 附近的点要和在那个点是同样。Okay. Does it make sense? So how to generalize this to two-dimensional? Our domain becomes what? R2. 我们变成 R2 了。Okay. So we have the extra what? Extra axis here. Okay, here x and y. 能够想象这个 delta 变怎样吗？如果我加多了一个 y axis 进来，能想象吗？ So in one variable, you just need to consider what? Delta from left, right. But now you consider 2D plane 哦，怎样 approach 一个点？有几个方式？比如说这个圆圈，有几个方式 approach 这个中间？几个方式？四面八方。So a lot of direction you need to consider internally maybe. 方式啊，现在 one variable 就左右吧。Then if it's 2D, you need to go from anywhere you can. 全部的 limit 都要 agree. OK， 全部的 direction 都要给你同一个 limit. Then 你的 limit 才 define. OK, does it make sense? Any question? So how to put it precisely? So to put it precisely, so we say that how do we define the limit of xy going to AB? Okay, if for all epsilon greater than 0, there exists a delta 一样的故事 such that when xy and AB the distance is less than delta, then the f value is also less than epsilon within L. Okay, no, the difference. So the difference is here. Okay, how do you compute this distance here? So how do you compute this distance here? Actually, this should use what? How to define the distance between 2 points? Huh? This is so what's this? This is the Pythagoras theorem. I don't know. Pythagoras theorem. So x minus a square minus y minus b square root. So meaning all the line forming straight line, all the point forming straight line for this can be. Ah, sorry. Come on. Come on. Oh, sorry. Thank you. Plus. Yeah. Plus in the middle. Thank you. Okay. So basically, you start with AB, and then you look at all the point around it. Okay. And then you compute what's the distance between AB and these points. So if you look at all point less than delta means what? It form a delta ball here. Okay. Delta ball. Correct or not? When it's equals to delta is what? 又是刚才我们的图片啊 square root of 什么 square 加什么 square 等于一个号。This is a circle. But we consider everything less than, strictly less than. Okay? So we just include the what we call the interior of the circle. Interior. Okay. Interior. 明白吗？听得懂我在讲什么对吗？我们才看你明不明白。如果听不懂，我再 repeat. Do you know about? Do you know how to see this part here as a ball? Ball, right? Yeah, it's a ball. Because we take everything inside the circle. But we don't take a circle 啊，我们拿它的 boundary 耶。其实这个东西叫做 open ball， 它是开的。Open ball. Later we will see this idea of open and closed and bounded for this class because we need it for maximum minimum theorem. Open. 这样子有问题吗 ？Feel free to ask 啊，如果我讲一些怪怪的东西。So let me draw this boundary. We need to take away the boundary. So let's take away. Okay, so the boundary we take away. This is what we call open ball. Open ball, right？其实没有离你会的东西很远，因为你懂一个东西叫做 open interval。为什么 open interval？为什么那个 interval 是 open 的？I mean, when I talk about open interval, what appears in your mind？来问一个人，建彤 ，Can you give an example of open interval? Sorry. Can we give a finite one? Yeah, 0 to 1 with open bracket, right? So why is it open? Because you don't take the two endpoint. Circle is the same. You don't take the boundary, what we call this, for the ball. Then you don't take the boundary. Maybe I didn't define these words properly, but can you get the idea or not? Can you get the idea? Boundary of a ball is a circle. 有 idea 吗？就是它的边边嘛，给它边边。Because interval, what's this? What's the boundary of this interval here? So you have 0 to 1, right? Okay, but you take away the endpoint. 它的边两个点被你拿掉。Okay, yeah. So, in this course, it's a bit challenging because sometimes we don't have a technicality to do it. But if I don't tell you these, you sure confuse one. You confirm confused. This is 这个就是原因，为什么有些课啊，你会听到 blah blah， 有些课可能他老师讲的蛮清楚，但是你还是不知道怎么算，因为那个老师没有把核心的东西告诉你。但是有时候要告诉你这些核心东西，不是要需要蛮多的语言来构建这个东西，所以有些老师会 skip 掉。所以你备考其实是你会备考一个你不会的东西，其实。所以为什么你会问为什么我读了这样多，我还是考70分、80分、90分？因为有些课你就是考不到，因为那个老师没有告诉你他的重点是什么，你明白吗？没有啦，至少这是我的讲讲我的心得，因为我是一个很努力的人，而且我自认我是把老师的话全部每一句都听进去了。但为什么有些老师课我就是考不出来啊？真的。后来我想清楚了，那老师有些东西没有跟我讲，他不是考我学，他是考我的天赋，你知道吗？明白吗？我很讨厌这种老师。OK， 我很讨厌这种老师。什么？Yeah，I mean， 像中学哪里有 evaluation 哦？中学都没有这种东西。对啊，中学都没有这种 evaluation， 就是老师讲就讲了。But 没有办法，这是一个过程啊。就是说，如果你遇到这样老师，你就是确实你自己要看一下你怎么去想到这种东西啊，不要靠老师这样讲。But I mean， 如果 for 我的话，我会 try to 讲 whatever I can 呢。Okay, to make sure that you know what is really going on. Maybe 有时候会 out of scope 吧，但 for sure 的一件事情是我不会考你 out of scope。什么叫做 out of scope 呢？就是说，如果我在班上口授，就是用嘴巴教的出来的东西，然后我们在班上大家 agree 的会了，这个东西一定会被考出来的。OK， 我不会考一个以外的东西。以外的东西是怎么 define 呢？是可以被推导出来的东西。就是说给你一个很简单的 example， 比如说我出那个 MEGE General Topology 的题目，他学生没有考过题目，哇，他觉得很难。考完过后答案给他看，不是，他学过的东西，只是他没有想到吧？这些东西会考，就是说那个答案是你知道该用这种东西，只是说你会不会在这个情况下知道要用这个东西，这个东西会考 ，OK， 而不是会考那种。你不知道，你没有看过那种 ，OK，Yeah，然后我的题目会藏 distinction point， 就是说，如果你能够想 extra，based on 我教你的，可以 go extra 一点的，这些会全部归类在 distinction point 里面，可能10分、15分是 distinction point。如果你拿到那个 point，你就是在这个班其实是很好，你已经 understand 全部了，然后你又可以 go forward further a bit，你明白吗？ OK，所以最基本的是先明白我讲什么先，不明白我的问题，你一定要问我的，OK，因为你想不到的，你再想你也想不到的，因为你就不知道我问题在问什么，对不对？你答案怎么会给出对的答案呢？不可能的。所以第一个，像慧琪刚才听不懂我的题目问我，因为有时候你会听漏嘛，合理的、合情合理，我也会听漏很长，OK，但是不合情合理的是什么？你没有尝试去理解人家讲什么，这是不合情合理的，不合情合理，不可以，这个不可以，这个会造成家庭悲剧。我告诉你，不是考试考废了罢了，这是家庭的悲剧。很长的家庭悲剧就是爸爸不要听妈妈话，妈妈不要听爸爸话，爸爸不要听儿子话，儿子不要听爸爸话，都是这样的。这些就是悲剧的源头，不听话吧？不是 obedient 的那种不听话啊，就是那种你没有去考虑人家的感受，或者没有考虑人家的那个意见。不是要你接受，但是你要去接上，合理吗？可以吗？很重要啊，很重要啊。OK，OK，right，OK, we talk about this not already, no need to be defined. And then if the limit must approach the same limit no matter what path. Okay, like what we told you just now, need to agree from any direction. Okay, for two-dimensional. Okay, in this case, showing limit is pretty hard for two-dimensional. 蛮难的. If you want to check that this limit is L, you need to go from different direction. But 这样的题目for contra, for negation 是很容易. Because if you want to check for all is true, how to negate? 好，两个不一样的就好了。Find two directions that don't agree, then limit 就不在了。Okay, so for all the statement, negation is easier to prove because you just need to find existence. But existence, you just need to find one. If you want to prove that existence statement is true, you just need to find one. Okay, so if you want to prove for all, then you just check for all. Okay, but you want to show it is false, then you just need to produce two that's not the same. Okay, I'll give the example also. 现在只是说 theory 吧，等下我们会给 example。OK， 听得懂吗？听得懂吗？听得懂啊？等一下我会给你 example，我会 show 给你看。OK，我们就是说 concept，然后我们说 example。Right， 我们看真正的 example，不要看这种讨论吧。OK， 来看 ，Let's see one real example here. Okay, so if you want to compute this limit here, what do you need to do? Where's the point we're interested in? Where is it? At the origin. Okay, so how should you imagine 呢？这个可能是一个graph 在 R3 里面 ，something like that。画刚才我们有画过的东西啊。Okay, something like maybe like this. Okay, 可能这样。And then you want to look at the limit approaching the origin. Okay. But we need to see from every direction here. So we try every direction. So what this table is doing, these are the coordinate for the point in R2. Okay, around 0, 0. Okay, can you see that it's around 0, 0? Because it's a bit away from 0, from the left and right. Okay, and then can you see any pattern here? No? 看得出什么 pattern? So really, you need to check at the 0, 0 point here. Can you see any pattern here? 为什么是空空的 ？How to compute this block here? What do you need to substitute? You substitute 0, 0 into your function. What do you get? 0 over 0, not defined. Okay, so we just discussed about limit. Okay, what can you see here? So if you go from outside, right, you can see that these values increase. How does this value increase? From 4 direction here. Okay, but when you get closer and closer to the origin, this value accumulates where? Accumulates around 1.0, really close to 1.0. Okay, no matter what direction you come in. Okay, as long as you get into a very close vicinity about the origin, you get value 1. Okay, so in this case here, we'll say that this limit is equal to 1. This is not how you calculate. In the exam, please don't produce this table up for me. This one will just give you a concept. Later, we will give you tools to calculate. Okay, and we won't use epsilon delta also, no need to worry. There's no epsilon delta in this class. Later, we'll give you tools. Okay, 比较容易算的东西. We will reduce to the case of calculus 1 and then we solve it. Okay, but 先不要紧张啊，这个只是 concept 吧。Okay, and then 还有另外一个情况呢 there's another condition here. There's another situation here. If you look at this function here, so what's the limit at this point? 那什么号码都有诶，不管从哪一个方向进来，不同号码。What is the possibility you will get? You are close to 0, 0. Maybe the value is 1. Maybe the value is -1. Maybe the value is 0. Okay, so if you come from different direction, you will approach different number here. Okay, does it make sense? So we will say that this limit here doesn't exist. Okay, doesn't exist. But from this limit here, can you construct the surface or not now? Can you construct our graph? 可以想象吗？这个 graph 是长怎样的 ？For 第一个 case, what did you see? If you are coming into this origin, can you see that the value is increasing? 有没有看到吗？那个 height 是 increasing. 来，炳雄 ，you see the height is increasing? 就应该是这样画这张图。你讲你的，我画一下。怎样画这张图？啊，怎么画这个图？啊，上去？从哪里上去？从哪里上去？啊，形容一下。形容一下，量上去。啊 What is this value? These are the f value, right? What did I told you how to imagine this value? These are the height of your domain point. Okay, so I mean, if I draw using the decimals, right, you'll see something like this. When you close to origin, the height increases. Okay or not? And then the top here is what? 1. Okay, the value 1. Yeah, so let's look at the other example. So how about the other example? What happens? If you go from the, what's this axis here? This is when x equals 0. So meaning this is a y-axis. Okay, if you go from the positive y-axis, it is negative. Okay, 可以想象吗? So let's draw it. So what is x, y, z here? X, y, z. Okay, if you go from the positive axis, the limit go to -1. Okay, so let's draw it. So, oh, it's not going to -1, or it's just keep at -1. So meaning here is -1. Okay, from the negative of y-axis is also -1. Okay, 一整条线都是-1在 y-axis 上面。How about x-axis? 想看 x-axis 找得出吗 ？x-axis 从这个格里面 x-axis is when y equals to 0. So what happens? The height is 1. OK， 在 x-axis 的时候，它的 height 是 always 1。OK， but if you go from the diagonal, what happens? It is 0。因为从那个 diagonal 进来的时候啊，全部是 0，所以你可以在你的脑里面拼这幅图出来嘛？你看，同一个方向是上去，一个方向是下去，然后你再 make sure 你的 diagonal 是0。我去画一下给你们看，旋转。你能画吗？你要不要画在你的 pad 上面？想象不出，想象不出诶。OK，let's draw it 啊，让我画一画给你们看。If you have a computer, you also can try. 看一下有没有 Isaac 讲的什么彩蛋。啊，都这个，有点太大，还是那颜色不是很好。那吗？还是转一转看。啊，好像看到东西了，看到吗？看到吗？看到吗？大家看到吗？减一在那里，加一在那里，然后0在那里。这样刚才又转不进去了。这样。哦，这个是你所谓的彩蛋呀？Is it？我还是想象不到。But can you see the negative one and then positive one part? And then can you see where's the 0 part? 那个 diagonal 的4个 diagonal 0，OK 吗？看得到吗？要不要暂停？还是你们 OK 吗？Can you see？来，慧琪，看得懂吗？看不懂。我看一下啊，有一个方向比较容易看。对啊，怎么变黑了？这个 OK 可以了。你想想看，这个 plan 啊，不是它的一 part，它的一 part 只有这个 purple 罢了。OK，你看一下 purple 这边什么发生？你看这一 part 是这个加1的高度，OK，and then 另外一个 perpendicular direction 是减1的高度，所以一个高一个低哦，make sense？OK，and then 从4个方向你会 intersect 这个 plane，这个 plane exactly 就是那个xy plane，当 z 等于0的时候，所以你看你会从4个方向去切它，有吗？有4个方向吗？你看1个、2个，然后再转过来3个，然后4个，你去有4个方向去切它，OK 吗？可以吗？可以明白吗？我看一下，拿我们的 data compare 一下，拿我们 data compare 一下，看一个方向减1，一个方向1，然后4个会切到那个z 等于0，就是 xy plane，z 等于0是 xy plane。回去玩一玩这个东西。我觉得这个颜色还不是很好，还有一个更花俏的颜色，我只是忘记了它的 website 叫什么名。以前一找就出来了，现在就我回去找一找，我再画给你们看。我放进 lecture note 里面。OK，还有问题吗？还有问题吗？1减1。所以你看这个照片其实很假，其实你看得出这个照片假吗？我们学过数学，我们就要知道这个照片蛮假的。假在哪里？来 test 一下，这个就学数学的人才会看得出吧。对称是 OK 啊，对称还是不对称？对称是 OK 的，但是就是说中间这个点是 undefined 的， limit 都不 exist， 所以其实它没有被连在一起的，其实要有一粒洞在中间，空洞呀，不应该连在一起，不 continuous 吗 ？OK， 我们不能够补掉那个 limit， 因为从各个方向来的点都不一样的 limit， 不能补掉，所以这边这一条线上面其实不可以有点的，所以它不可以紫色一直指到完，中间要有一个空的东西。明白我讲话吗？不 continuous 这个图一开始，我试下 Desmos 啊，如果有什么不一样，我给你看。试下 Desmos。Desmos 也是 Desmos 还比较好看一点。OK，Desmos 比较容易看一点，因为它这条线是另外一个颜色，这条线应该是空的。哎，Desmos 比较好看的啊，比较好看这个呀。Contrast 这种 3D 图啊，你要有 contrast 你才容易看呀，contrast 不够不好看，不难。不 symmetry 是因为它画的不够长，然后再画长一点就是同一边东西了。OK 吗？会比较容易看吗？慧琪？还是还看不懂？看不懂不要紧，再问吧，一定要问到懂为止，因为大家都懂了这个东西，所以是懂得了的东西，而不是不懂的。OK， 看得到吗？你看有4个线，那个xy plane，xy plane，and then and then 减1 on the other side。OK， 有问题吗？还有问题吗？So it's a very good tools Desmos 这些 GeoGebra 还是什么？我再去找一个很 colorful 的，我以前用的，去找一下给你们讲。那我放在 lecture note 里面。OK。So these are just a checking point. Okay, I think we almost finished already. Okay. So let's stop at limit here. So I haven't taught you any tools yet. So following, we will continue with how to compute a limit actually. Okay. Okay, we'll see you next week. So please prepare your tutorial question before our revision class, okay? So you can ask me a question. We can do it together, actually. Go through these questions that you